работу на лучших условиях среди сотен тысяч вакансий на Авито. Например, с зарплатой побольше. Авито, здесь решают люди.
Lui, c'est la réalité de l'entrepreneuriat. Et ça, c'est tout l'argent que vous gaspillez. Et Will Smith peut vous le confirmer.
All with ease. You can use a keyboard or a third-party joystick controller to give Spot instantaneous commands, like move left, right, forwards, or backwards. With Touch to Go, you can also click on a location in the environment, and Spot will automatically navigate there. This is great for precise navigation over high-latency network connections. In addition to teleoperation, Scout lets you kick off pre-recorded auto-walk missions to support repeatable inspection routes with no on-site supervision. You can observe Spot's autonomous execution of the mission while working on other projects. If an anomaly occurs, you can intervene, take over manual control to get a more detailed look if needed, and take steps to resolve any issues before problems become critical. Scout allows Spot to be your eyes and ears on the ground. To test Scout and other Spot capabilities, the Spot development team operates a 24/7 unstaffed lab which we access over VPN. This lab has helped us build and test a number of features focused on robust remote operation. In developing Scout, we made sure that it maintained the same features a user would find while driving Spot with a tablet. For one, Spot has built-in obstacle avoidance. Even if the operator attempts to drive Spot directly into an obstacle, such as a metal pole, Spot will automatically detect the obstacle and walk around it. Obstacle avoidance can be adjusted and decreased for a situation needing tighter clearance, or increased to create a safer, larger cushion. Spot also handles stairs well. By turning on stairs mode, Spot will automatically detect stairs, including open riser graded metal stairs, and walk smoothly up and down them. Operators using Scout can get more situational awareness before descending stairs by looking backwards, or by enabling terrain mode, which shows a real-time feed of the 3D geometry around Spot. Spot has a number of advanced mobility settings which can help with navigating through difficult areas. Operators can choose to adjust Spot's speed and have the robot walk slowly when going through tight quarters. They can also adjust the robot's height. To get past overhangs, such as crossbars, operators can have Spot walk in a lower stance to get them through without colliding. Docking is a one-click operation. Operators just need to get Spot close to a dock. Once there, simply click the dock button and Spot takes care of the rest. Spot navigates to an approach point, backs up, and slowly descends to start charging. Although Spot is a remarkably stable robot, occasionally disturbances can happen and the robot can fall over. But there's no need to send someone out in the field in this case. Click self-right and Spot will automatically get itself back in an upright and seated position. Then you can resume normal operations. Spot can also recover if it ends up in a communications dead zone. For example, if Spot walks out of range of a Wi-Fi access point. With auto return, when Spot detects that it has lost a communications link, it will retrace its steps until it starts receiving commands again. Collaboration is built into Scout. Scout supports multiple spots and multiple users on a single server. Although each spot can have only one operator at a time, there can be multiple viewers watching what that spot is doing. For example, If an operator comes across a leak or another problem in their facility, they can send a link to a supervisor who can quickly assess the situation by opening the view mode in their browser. We've also designed Scout to be easy to deploy. Scout runs on an on-site one-use server. The software comes pre-installed, so all you need to do is rack it, power it, and provide network connectivity. There's a web-based administrative console to configure the server's networking, users, and robots it can communicate to. We know information security is important to you, and we're confident the security infrastructure in Scout will meet those needs. Scout can run over a VPN, or you can choose to run Scout in an isolated network with as tight restrictions as you require. The Scout system never needs to connect to the internet. All access to Scout is restricted to authenticated users only, and all data is encrypted in transit and at rest. Just like Spot's software, we plan to continue to enhance and improve Scout with regular updates. In upcoming months, you can expect a regular cadence of new feature deployments. For more on how we're enabling you to use Scout, let's go back to Michael.
As Chris mentioned, Scout makes safe, efficient data collection simple. But we've learned that moving to a complete solution includes more than a capable robot and easy-to-use software. Together with the Spot Enterprise Robot, Scout software, our SpotCam plus IR payload, and premium support, we are proud to offer an out-of-the-box solution for collecting data in remote or dangerous environments. This operator-ready solution will provide the data you need to proactively maintain and manage your assets, maximize uptime, and save on operating costs. It took us many years of development to get Spot capable of walking through complicated, rugged terrain that have been difficult for traditional automation. And now we made it easy to access data in these remote environments. Beyond data collection, however, we are focused on how Spot not just senses the world, but how it interacts with the world as well. Today, we are officially launching the Spot Arm, which will ship with several autonomous capabilities, including the ability to open doors and turn valves. But we also believe that the ecosystem of researchers, developers, and operators using Spot today can enable the ARM to do even more. That's why we are also shipping an API that makes it easy to develop new applications for the Spot Arm. To talk with us more about the Spot Arm, what it will ship with, and how it will enable our customers, here is Al Rizzi, our Chief Scientist.
Thanks, Michael. We've been experimenting with mobile manipulation since our early days, working on robots like Big Dog. Everyone has seen stationary robot arms of many sizes and speeds designed to do all sorts of tasks, but we've yet to see really capable and successful mobile robotic arms. This video, which dates to 2013, shows Big Dog using its entire body in concert with a high-performance arm to throw a cinder block roughly 5 meters. The coordination you can see between the arm and the body in this video is at the core of our approach to mobile manipulation and represents a core capability we are striving to make available on Spot. So, throwing cinder blocks is fun, but Spot can also have some fun with its arm. Here we see 3 Spot robots playing together. This jump rope behavior you see here serves to demonstrate both the capability of the robot and arm hardware, as well as the software suite that controls and coordinates them. While jumping rope may not be particularly relevant in an industrial setting, we hope you can appreciate the capability that a quirky and fun scene like this demonstrates. But, as I said at the outset, we have much greater aspirations for Spot than merely performing stunts like jump roping. Based on discussions with early users, it is clear to us that the main themes that make Spot valuable to applications in construction, utilities, oil and gas, and manufacturing are equally relevant when we think about mobile manipulation. This makes us very eager to deliver mobile manipulation capabilities that build on our experience in advanced mobility, autonomy, and control. Our intent is to make it as easy to perform manipulation tasks with Spot, in much the same way that Spot has already made it easy to locomote through complex environments. The arm we developed includes 6 degrees of freedom in addition to a gripper. The overall length of the arm is approximately 1 meter, and when combined with the mobility of the base robot, results in a system that can flexibly access all of the environment around the robot. The arm weighs only 8 kilos, but is capable of picking up and carrying roughly 5 kilos. This gives the robot ample strength to interact with typical objects that the robot is likely to encounter in its environment, including dragging things like cinder blocks. The arm is fast enough to move the end effector at velocities of up to 10 meters per second, making things like the jump rope demonstration possible. Finally, we have included both an imaging depth sensor and a 4K RGB camera in its gripper, making it possible to see objects that the robot is manipulating and perform inspection tasks. This initial release of the arm will ship with 2 primary modes for controlling it. You can use the tablet to directly teleoperate the arm to perform one-off inspection or manipulation tasks. Alternatively, you can access all of the ARM functions through an API, much like you can remotely control locomotion. This enables development of novel autonomous control strategies, or even allows you to build your own custom teleoperation interface. Out of the box, both of these interfaces provide access to basic kinematic control of the arm, as well as a suite of more complex behaviors which incorporate supervised autonomy. This is very similar to how we've tried to make Spot's mobility a seamless experience for the user, where you simply tell the robot where to go, and the robot decides how to place its feet and maintain balance. In the case of the arm, the user tells the robot what to grasp or how to interact with the environment, and the robot makes the necessary local decisions in order to complete the task.
Это не женский, все-таки согласен, да? Быть родной, это ближе уже как-то, да, тема. Тоже непонятно. По-английски говорить, если не по-английски, наоборот. Вот быть понятно. Меня это не волнует. Это не проблема. Женщина, здорово. Хорошо, это все понятно, что жизнь такая, как функционировать. Беременность. По логике просто. Для ебли равно сперма там, где надо. Если вернись к предыдущему. Беременность. Роды и применение другие. Беременность, роды, применение женское, имею в виду. У меня нету разницы, понял, что у меня нет. Ну нет, у меня не мужская. Ну нет, у нас спектр. Оно, наверное, и есть то, что ты называешь любом. Безусловно. Но это не совпадает со счастьем, ты хочешь сказать. Да. Это как бы нет, ты имеешь право сказать все, что угодно, а на самом деле не так, понимаешь? На самом деле, я понял уже просто, насколько ты далек от этого просто. А ты будешь смеяться, но это только всего лишь то, что тебе, да, ну ты понял, да. Ну это плохой мир, он тебе такой плохой весь, я понял. Работать надо, понимаешь, и сдаваться. Да. Ну да. Значит не быть вообще. Не за мой счет я тебе объясняю. Я могу с этим вот так вот смириться. Но да, если ты мое, то все мое. Беременная постоянно. Ну нет, так несчастливые зато, да. Ну ладно, не надо. Да, понимаю. С ума сойдешь, посойдешь.
The arm is a tightly integrated add-on for the robot. This is important as it allows the entire system to maintain balance and take advantage of the underlying mobility when being used to manipulate the complex environments we expect the robot to be used in. And while the arm can only be attached or removed by Boston Dynamics, there's room for additional sensors under and behind the arm so that the platform can still be customized for specific applications even once the arm is mounted. This video demonstrates the robot being teleoperated to manipulate a variety of objects. We start by using a semi-autonomous grasping behavior to grasp and drag a hose. We can also see how the large workspace afforded by the combination of the arm and Spot's mobility can be used to nudge a container on the floor. Finally, we can see how the sensors in the gripper can be used to semi-autonomously grasp, pick, and place a tool. In this next video, we can see a more complex integrated behavior being used to interact with the switch. We foresee this type of constrained manipulation or interaction will be central to many of the use cases for mobile manipulation on Spot. This same type of interaction can be used to open doors. Here we see a fully automated door opening behavior we have developed in action, allowing the robot to quickly traverse a standard door. The door opening behavior merely requires the operator to point the robot at the door handle and tell the robot which side the hinge is on. After that, Spot takes care of all the details of pushing or pulling the door, using its foot to hold the door open while it re-grasps the door and completes the task. Finally, you can even use the in-gripper color camera to perform inspections. Here we can see an operator inspecting a leaky pipe and using those semi-autonomous constrained manipulation behaviors to grasp and close a valve. We are looking forward to deploying the arm. First, the operator to point the robot at the door, and the robot makes the necessary local decisions in order to complete the task. The arm is locomotion. This enables development of novel is manipulating and perform inspection tasks. This initial release of the arm will ship with two primary modes for controlling it. You can use the tablet to directly teleoperate the arm to perform one-off inspection or manipulation tasks. Alternatively, you can access all of the arm functions through an API, much like you can remotely control locomotion. This enables development of novel autonomous control strategies, or even allows you to build your own custom teleoperation interface. Out of the box, both of these interfaces provide access to basic kinematic control of the arm, as well as a suite of more complex behaviors which incorporate supervised autonomy. This is very similar to how we've tried to make Spot's mobility a seamless experience for the user, where you simply tell the robot where to go, and the robot decides how to place its feet and maintain balance. In the case of the arm, the user tells the robot what to grasp or how to interact with the environment, and the robot makes the necessary local decisions in order to complete the task. The arm is a tightly integrated add-on for the robot. This is important as it allows the entire system to maintain balance and take advantage of the underlying mobility when being used to manipulate the complex environments we expect the robot to be used in. And while the arm can only be attached or removed by Boston Dynamics, there's room for additional sensors under and behind the arm so that the platform can still be customized for specific applications even once the arm is mounted. This video demonstrates the robot being teleoperated to manipulate a variety of objects. We start by using a semi-autonomous grasping behavior to grasp and drag a hose. We can also see how the large workspace afforded by the combination of the arm and Spot's mobility can be used to nudge a container on the floor. Finally, we can see how the sensors in the gripper can be used to semi-autonomously grasp, pick, and while the arm can only be attached or removed by Boston Dynamics, there's room for additional sensors under and behind the arm so that the platform can still be customized for specific applications, even once the arm is mounted. This video demonstrates the robot being teleoperated to manipulate a variety of objects. We start by using the semi-autonomous grasping behavior to grasp and drag a hose. We can also see how the large workspace afforded by the combination of the arm and Spot's mobility can be used to nudge a container on the floor. Finally, we can see how the sensors in the gripper can be used to semi-autonomously grasp, pick, and place a tool. In this next video, we can see a more complex integrated behavior being used to interact with the switch. We foresee this type of constraint manipulation or interaction will be central to many of the use cases for mobile manipulation on Spot. This same type of interaction can be used to open doors. Here we see a fully automated door opening behavior we have developed in action, allowing the robot to quickly traverse a standard door. The door opening behavior merely requires the operator to point the robot at the door handle and tell the robot which side the hinge is on. After that, Spot takes care of all the details of pushing or pulling the door, using its foot to hold the door open while it re-grasps the door and completes the task. Finally, you can even use the in-gripper color camera to perform inspections. Here we can see an operator inspecting a leaky pipe and using those semi-autonomous constraint manipulation behaviors to grasp and close a valve. We are looking forward to deploying the arm and its initial set of features with a broad set of users. We are sure these new capabilities will enable users to discover what mobile manipulation can add to their business and help us continue to support the variety of use cases people are eager to explore.
It has been so exciting for us to see Spot doing incredible things in the hands of our customers. And this day marks a new chapter for Spot. We've moved from offering Spot as a platform for developers to offering an out-of-the-box solution that's operator-ready. The measure of success is not that we can make the robot work, but that you can. I hope you like these new Spot capabilities. I can't wait to see what you will do. Thank you for joining us today. Stay well and stay safe.
Сбербанк запрещено законом. Воспоминания о Ласкале уже надоели. Паблик ВКонтакте, мне надо его ввести, чтобы туда ввести. Брат, был жив. Значит, ты злой просто, и все. Нет, ну да. Что, не работаешь в коллективе? Нет, наоборот. Нет, наоборот. Наоборот, значит, да, вот это имеется в виду. А, деньги получать надо. Я не... Что за бред? Ну вот это имеешь в виду. Ну вот это имеешь в виду. А, подставил, что ли? Себя ты подставляешь. Тебя подставили нельзя. А, ну да. Да, вот это есть. А, то есть это штука, когда типа деньги с ним сделать, это наоборот. Уважать надо, типа. Как бы уважать, типа. А, вот так, да. Ладно, да. Г. Яды. Следовательно говоря, да? Следовательно говоря, понимаешь меня, да? Понимаешь? Вот кто знает, ты смотри, вот ты мужик, взял жену, ты сказал, она будет моей всегда, а она не беременная. Ты очень грубо за это все будешь, понимаешь? Да. Всю жизнь прожила, и при этом она здоровая была, например. Или ты был здоровый, ну, так не важно. То есть тут не о чем говорить. Ничего, здесь нет таких вопросов. Пусть ему раздал и все. То есть как бы нету вопросов, таких не существует, да. Ну раздал там, это не важно. Это не важно. Это вторичный вопрос. Я тебе сказал, я тебя предупредил. Тоже не твое дело. Не мешай человеку, да. Ради этого играл, нет, нет. Что, да. Нее. Понял, да. Ну да. Чтобы бытом занимался, грушевидным, бесполым, здоровым, не сумасшедшим, вменяемым, хорошим, не импотентным, не безобразным, не псатым, сумасшедшим, наоборот, своему месту. Просто я тебя предупредил, короче. Она должна быть беременна всю свою жизнь, пока такая менструация есть. Ну пока, да, не по-другому. Просто есть или нет? Ну, я тут терпил. Ты будешь терпил, да. Это нормально, понимаешь? Это больше бы сказал. А кто знает, может это есть самое. Я понял. Ну нет, это просто уже понятно, знаешь. Здесь ничего не. Ну это что, сколько это стоит? Ну я понял. Ничего. Ну вот, понимаешь, это все лишь объем работы мужской. Что-то да. А что они ласковые, беременные, что решают? Нет. Ну уже не надо, чтобы ты дома был, не с ума сойти, если не куда-то, если ну ладно, я не писатель. Ну, чтоб ты возвращался, надо, да. Нет, я не знаю, ты спрашиваешь. Веду тебя. Дистанционно смотрите. Ага, да. Композитор. наоборот, потому что...